Hi there, and welcome to this lesson on Pure Mathematics 2. And in this lesson, we're on Chapter 4, 4.1, and we'll be considering how Pascal's triangle is used with the binomial expansion. Now, Pascal's triangle, the numbers in Pascal's triangle, there's an extremely close relationship between them and what's called NCR. Now, what is NCR? NCR can be read as N choose R. What does that mean? Well, for example, if you had 6 children in a class and you wanted to choose 3 out of those 6 children, then 6C3 or 6 choose 3, it gives the total number of different ways of choosing 3 out of the 6 children. How do you calculate it? Well, there are several different ways to calculate NCR. The formula for NCR, which is sometimes written like that, it's also, you'll notice, sometimes written as a vertical bracket, N over R. They mean the same thing. It's equal to N factorial divided by R factorial times by N minus R factorial. So using the formula, 6 choose 3 would be 6 factorial divided by 3 factorial over 6 minus 3 factorial. Put all of that in the calculator and you get 20. So that's saying there'd be 20 different ways of choosing 3 children out of a group of 6 children. Another way is just using the NCR button on your calculator, if you have one. And if you've got a calculator, then just quickly check that you can use it. It's normally hidden over on the right-hand side. And if you put in 6C3 with that button, again, you should get 6 choose 3 is equal to 20. There is a third way of calculating NCR, which for the binomial expansion can be very useful indeed, and it uses Pascal's triangle. What's Pascal's triangle? Well, it begins like that. Each number is calculated by adding the 2 numbers directly above it. So the 3 here, it's 3 because you do 1 plus 2, that gives you the 3. The 2 here, 1 plus 1, that gives you the 2. I'll let you have a go at just completing Pascal's triangle until you get down to the 6th row. So the one that begins 1, 6. I'll let you have a go at doing that yourself. So pause the video, complete Pascal's triangle down to the row that begins 1, 6, and then start the video again. Okay, let's have a quick look at that. If you've seen Pascal's triangle before, you'll find this very easy. Each number is the sum of the 2 above. So the next row would be 1. 1 plus 3 gives you 4. 3 plus 3 gives you 6. 3 plus 1 is 4. And then 1 plus 0 will give you the 1. For the next row, you get 1, 5, 10, 10, 5, 1. And then for the 6th row, 1, 6, 15, 20, 15, 6, 1. Now the numbers in Pascal's triangle are the numbers that correspond to NCR for that row. So we've got the 6th row here that goes 1, 6, 15, 20, 15, 6, 1. Those numbers are 6 choose 0, 6 choose 1, 6 choose 2, 6 choose 3, 6 choose 4, 6 choose 5, and 6 choose 6. So we were working out 6 choose 3 just now, and we got 20 for the answer. Using Pascal's triangle, you've got 10 plus 10 here, and that gives you 20 again. A very, very useful application of this is where you have a bracket, a binomial bracket, being expanded to some power. So for instance, if you had x plus y all to the power of 6, and you wanted to expand that, now you've got 6 brackets being multiplied together. Obviously, you could just multiply the 6 brackets together and get the answer. The binomial expansion gives you a much, much quicker way of doing that. Now, the first thing is just thinking about the different types of term you'll get. So if you do x plus y to the power of 6, I could do the x from that bracket times by the x from there, times 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 the x from there. And that'll give me an x to the 6th term. Or I could choose x from 5 of the brackets and y from the other 1. That'll give me terms in x to the 5 times y. Or I could choose x from 4 of the brackets and y from 2 of them, x from 3 of the brackets, y from the other 3, x from 2 and y from 4, x from one of the brackets and y from the other 5, or I could choose y from every single bracket. Now, look at the pattern there, because that pattern is what you always get when you're using the binomial expansion. You'll notice that as you move through, the powers of x go down by 1 each time. The powers of y go up by 1 each time. If you add the two powers together, you should always get 6. Here we've got y to the power of 1, so 5 plus 1 is 6. Now, those are the terms. The only other question is, how many of each am I going to get? Well, the answer to that is you're going to get NCR. So for the x to the 6th term, I was choosing x from 6 of the brackets, y from none of them. That's 6 choose 0. For this term, I was choosing x from 5 of the brackets and y from 1 of them. X from 4 of the brackets, y from 2, and so on and so on. And these numbers are just the numbers in the 6th row of Pascal's triangle. So they're those numbers. All I have to do is put those numbers down as the coefficients for each terms, and that is x plus y to the power of 6 completely multiplied out without having to multiply any brackets together. Okay, let's see if that makes any sense. Gets slightly harder if you don't just have y, if you have something like 3y or 2x. But I'll let you have a go at doing this. So we're asked to find the full expansion of x plus 3y to the power of 4. That means we're going to be looking at this row here, the 4th row of Pascal's triangle. And we'll get the same pattern as before. Instead of y now, we're going to have 3y. I'll let you have a go at seeing if you can make sense of what all of that means. So pause the video, have a go yourself, then come back to me when you're ready. Okay, let's have a look at this. So the first thing is just getting the pattern in the terms. If it's to the power of 4, then the first term will be x to the 4. Then we'll get x cubed and 3y to the power of 1. Then x squared and 3y squared. Then x to the power of 1 and 3y cubed. And then 3y to the power of 4. So a bit like on the first example we looked at. The terms follow that pattern. This time, if you add the powers together, you always get 4. Because we're doing a power of 4. The only other thing is, what are these numbers going to be? Well, these numbers, these coefficients, will be the numbers in the 4th row of Pascal's triangle. So it'll be 1, 4, 6, 4, 1. The only thing that's a little bit trickier on this question is here we've got 3y to the power of 1. Here we've got 3y squared, 3y cubed, 3y to the power of 4. So taking those powers of those brackets, that'll give us 3y here. This will be 9y squared. When we square it, 3 cubed is 27, 3 to the power of 4 is 81. And then we're going to have to multiply together these numbers. So the 6 times the 9, the 4 times the 27, and so on. And that gives us the answer. X to the 4 plus 12x cubed y plus 54x squared y squared plus 108xy cubed plus 81y to the 4. I hope that made sense. I'll have a go doing another question. This time we've got 2y minus 3. Again, it's to the power of 4. So we'll be using the 4th row of Pascal's triangle to get the coefficients. Two things to be careful with. First of all, we've got 2y here. And the other thing is we've got minus 3 this time. So we'll be doing minus 3 and minus 3 squared and minus 3 cubed. I'll let you have a go at working your way through all of that. So pause the video, have a go at doing this, and then come back to me when you're ready. Okay, let's have a look. So that bracket to the power of 4, the first term will be 1 times by 2y to the power of 4, 1 coming from this 1 here. The next term will be the 2y cubed times by minus 3 to the power of 1. We'll have 4 lots of that, taken from the 4 here. Then 2y squared times minus 3y squared, 6 taken from the 6 there. Then 2y to the power of 1 and minus 3 cubed times by 4. And then last of all, just minus 3 to the power of 4 times by 1 from this last one here. As on the last example, we're going to have to do this bracket to the power of 4, this bracket to the power of 3. And we're also going to have to be careful with these numbers here and the minuses. So, first of all, 2y to the power of 4. 2 to the power of 4 is 16. 2y cubed, 2 cubed is 8. Minus 3 to the power of 1 is just minus 3. 2 squared here will give us 4y squared in total. Minus 3 squared is plus 9. 2y to the power of 1 is just 2y. Minus 3 cubed is minus 27. And minus 3 to the power of 4 is plus 81. Hope you can see where all of those numbers come from. To tidy this up, we're then just going to have to multiply them all together. So here 1 times 16, here 4 times 8 times minus 3, and so on for the other terms. And that'll give us 16y to the 4 minus 96y cubed plus 216y squared minus 216y plus 81. Okay, example 3 is a slightly different type of question. We've got the expansion of 1 plus ay to the power of 6, where a is some constant, but they haven't told us what. What they have told us is that the coefficient of y squared is 135. And we're asked to find both possible values that a could take. So we'll be looking at the 6th row of Pascal's triangle. The y squared term is going to correspond to the 15 here. Now, I'll let you have a go at making sense of this yourself. So pause the video, see if you can work out what's going on, and then come back to me when you're ready. Okay, let's have a look. So the y squared term, it's made up of 3 things, and you just need to understand where all those 3 things come from. First of all, we're going to have ay squared, and that'll give us the y squared. The other term is just 1, because we've only got 1 here, to the power of 4. And you know it's 4 because these 2 numbers, the 4 and the 2, always have to add together to give you that power. So 4 plus 2 gives us the 6. And then the 15 comes from the 15 here. That'll be the y squared term. That would be the y to the power of 1 term. And that's the y to the power of 0 term, where you would just have the first thing here. Normally it's x. But I hope that makes sense. So this first term here is really the 0th term. This would be the y to the 1 term. This would be the y squared term, which is why you get 15 there. Now multiplying that out gives us 15a squared, y squared. So the coefficient of y squared, we've just worked it out, it's 15a squared. But we're also told in the question that the coefficient of y squared is 135. So 15a squared here must equal 135. They're both the coefficient of y squared. This we can solve in the normal fashion. That'll give us a squared equals 9. And that gives us 2 possible values for a. Either a is equal to plus 3 or a is equal to minus 3. And that's the answer. Okay, if you've got the textbook, then turn to page 64 and have a go at exercise 4a. Thank you very much for listening, and cheerio.